Our industry historically may not have been the coolest, but we're becoming a cool industry.
Why is Tennessee so interested in energy?
We've made for the last 10 years significant investment to renew our industrial portfolio.
We're facing certainly unprecedented demand, for the equipment solutions that we manufacture.
We want to move fast. The people who are going to build these plants are 18 and 20 years old right now. I need tools, I need innovative tools of which to go do that. We are on the cusp of an industrial revolution, a new industrial revolution.
We welcome to the stage Braden Stover, Matt Rasmussen, Jean-Luc Pallier, and Jason Neal.
Well, good afternoon to you all. I feel like Dolly Parton up here. Is that Dolly? Well, we said NSYNC backstage, yeah. So we got this headset thing going on. But thank you all for being here. I will start by saying I've been on the road since 3:30 in the morning, coming from Oak Ridge, Tennessee. So as we talk about energy, we want to start there. Kind of why is Tennessee so interested in energy, and why should the country be interested in energy? And so Governor Lee put together a fund here in Tennessee that we operate with the Department of Economic and Community Development to recruit companies to the state. And power is a huge need there. And so we have a star-studded panel here, and I want to start with you guys to just give a little overview of you, what your company you work with. And kind of how you guys intertwine with the energy space. And we'll start with you, Matt.
Yeah, so good afternoon, everybody. My name is Matt Rasmussen. I'm the Chief Nuclear Officer as of 2 weeks ago for the Tennessee Valley Authority. And our job is to make sure that everybody in this room has power for your facilities. And so we serve about 10 million people in 7-state region here in the Tennessee Valley.
Hello, I'm Jean-Luc Pallier. I'm the CEO of Orano USA. We're one of the world's leading nuclear companies. We do everything from uranium extraction, enrichment, spent fuel reprocessing, and recycling. We've been in the United States for 60 years, so we're one of the oldest nuclear companies established in the US. We have about 400 employees, 15 facilities, and just recently we announced our very large investment project in Oak Ridge, Tennessee, where you were, Brandon, this morning. A $5 billion investment that will really change the nuclear fuel supply chain for national security.
So good afternoon, Jason Neal, president of Yosung Heiko. We've been in the U.S. since 2001, but we opened up a power transformer manufacturing operation in Memphis, Tennessee in 2020. We're a supplier of switchgear and fax solutions, DC transmission solutions here in the U.S., and proud to call Tennessee as our manufacturing hub.
Very good. Jean-Luc, can we start with you? Seeing as this is our 50th panel that we've been on together over the past 2 weeks,
yes.
It's an exaggeration, but the investment that Orano's made, given the increasing global demand for uranium, what is Orano's strategy to secure a stable supply? And then how does Project Ike, that you just mentioned in Oak Ridge, help solve for that supply demand?
So we've made for the last 10 years significant investment to renew our industrial portfolio to ensure that our customers, in particular the US utilities, they can get uranium conversion and enrichment with no disruption. So we were one of the first companies in the Western world to build the largest nuclear enrichment facility in Europe. So it corresponds to about half of the US needs in terms of enrichment services. It was built in it was in operations in 2011. And when the war in Ukraine started, we decided to expand the capacity upon the request from our customers, in particular in the US, to get access to enriched uranium free from Russian influence. We also built a very large conversion facility. So all the conversion facilities in the Western world were built in the 50s. They are very old, they are aging. They don't meet all the latest requirements in terms of environmental standards. So we have the largest conversion facility in the Western world. And also we are exploring new mines. We need to find new mines to produce uranium. So our mines are currently located in Canada, Kazakhstan. We started explorations in Mongolia and Uzbekistan. and we have some discussions also with some key partners in the United States. Project Hack is very, very important. So I have a question for the audience. Do you know how much do we import of enriched uranium from overseas today? Guess. Sorry? Not so close, but I heard 80%? Yeah, 70% exactly. And how much from Russia and China, do you know? About 30 to 40%. And our goal with Project Hack, the significant investment we want to make in Oak Ridge, Tennessee, is to restore the domestic capacity of enriched uranium to ensure that the US utilities and the advanced reactors will have access to enriched uranium free from Russian influence. And it will be the largest foreign direct investment ever made in the state of Tennessee.
That's right.
Do you agree?
I agree. And we love it. And we really appreciate that investment and the jobs that are going to come with that. So
Yes.
It's all good stuff. Matt, can you talk about, from TVA's perspective, the cost and duration of building new nuclear plants has historically been a major challenge. How is TVA going to overcome that hurdle and deliver more predictable and economically viable path to new nuclear capacity?
So there is no doubt that historically new nuclear is very expensive. Nothing costs in a nuclear plant starts with an M, right? It all starts with a B. And I do want, before I answer that question, I do recognize that a large portion of the U.S.'s supply of uranium comes from outside the U.S. That is not the case for the Tennessee Valley. And so we are homegrown energy. We procure all of our sources from sources. So that is a we're really proud of. So if you think about the cost of a nuclear plant, what gets you in trouble? What gets you in trouble is getting a little ahead of your skis. You saw that in some more recent builds where in the industry, we started to build a little bit before the design was ready or we were ready to go. So a big part of de-risking it is having a predictable design that's really, the risk of that design is understood and taking a systematic approach to building that plant. So that's a piece of it. And we're taking that approach right now with our Clinch River project with our BWX 300, a very systematic approach. We want to move fast. We want to move. Matter of fact, we just submitted the very first construction of permit application for Clinch River last spring, and we're looking forward to a return from the NRC to allow us to start construction in the early 2027 time period. So that's very exciting for us. So that's one piece, is really understanding the risk. We do have one advantage we have with the BWX is that is actually being built first by OPG. And so we're partnering with them to really understand all the learnings they have in construction. The second part of really de-risking the cost of a plant is partnerships. It's really about how we create partnerships between the developer, the transmission, the off-taker, to de-risk that, such that while we do need to go build these power plants, we're not asking the single mom at the grocery store to find a way to make that happen, right? Affordability matters. And so those partnerships really address the affordability piece of how we're going to build new nuclear. And I will mention one other thing that I really think the people in this room have an opportunity to help with. When you think about and you hear these stories from construction of power plants, people walking around with wagon loads of 6-inch 3-ring binders, that's the paperwork and the process to go build a power plant. You know, when we think about our workforce, the people who are going to build these plants are 18 and 20 years old right now. I can't give them a 3-ring binder and say, go build this thing. I need tools, I need innovative tools of which to go do that. And I think technology is a huge part of that. And I really believe that technology is one of our biggest opportunities to de-risk and limit the impact of some of the cost of new nuclear.
Very good. Jason, so transmission came up with TVA. I wanted to pivot to you. How are your power transformers and other HYCO solutions evolving to handle the increasing load and intermittency from renewable energy sources? And how does this affect the integration of base load nuclear power?
Sure, great question. So, I think we're facing certainly unprecedented demand, for the equipment solutions that we manufacture. It's, data centers are certainly driving it, onshoring of manufacturing here in the States, and this expansion of transmission. You told me there'd be 765,000 volt transmission being built in Texas a few months ago. We would have thought you were crazy, but we're a leader of that as well. So a lot of things we're doing to try to address it. It certainly is expanding our capacity to supply these solutions. So, we had an announcement back in May that, we are expanding the capacity to produce power transformers in our Memphis factory. So by the end of next year, we'll be the largest supplier of large power transformers in the U.S. So it was exciting hearing Senator Blackburn this morning saying Tennessee's #1. So hopefully we'll be a small part of that. But we're looking at it globally as well. So our ability to produce more transmission class breakers and high voltage substations and innovate with DC solutions and STATCOM. So, it starts with capacity, but really it's not just, it can't just be building buildings and putting equipment inside. It's developing expertise. We're blessed with a phenomenal workforce in Memphis. There's a lot that goes into that, partnering with universities, trade schools. Certainly as an industry, we need to do more of that. Coming up with solid training programs so when the factory is ready for that capacity to build, that we have the folks ready to build it. And it really is, safety and operating safely and manufacturing quality is really related to our folks. A lot of cool things discussed this morning. I've learned a lot. Our industry historically may not have been the coolest, but we're becoming a cool industry. So I think we need to get that out there a little bit more and attract more folks into our industry as well. It goes beyond the product. It's studying how these solutions are going to be integrated into the power system. If it's SMRs or STATCOMs, HVDC, there's a bit of a shortage of those engineers that know how to study the system and the impacts that these devices and systems will have on the system. We're trying to ramp up, but again, I think as an industry as a whole, we got to answer the call. And I think the last aspect is just construction and making sure, I'm encouraged. A lot of our partners in construction are ramping up to build out the transmission and interconnect data centers and new loads, hiring 1,000 construction workers. But again, there has to be a focus on the people side. We're answering the call with capacity adds for transformers and switchgear and STATCOM and DC solutions, but it's people, and we really have to focus on that, partner with universities and trade schools to attract that talent and keep it in our industry.
You're exactly right. And that's something that we focused on at our department is we've actually looked at how can we get into K through 12 and get to students that are in second, third grade, get them interested in nuclear, because at the rate that these projects are going, it's going to take some time to get construction built out. And so our second graders of today are going to be the graduates of tomorrow when these plants are all up and running. And so the quicker and the sooner that we can get to students and get them engaged, the better off we're going to be. So I'm glad you made that point about workforce. But
so Brian, so if I may add, because one of the reasons we decided to come to the state of Tennessee for our huge investment is thanks to your training program. And we partnered with the state of Tennessee, of course, TNECD, but also University of Tennessee, Tennessee Tech, to get access to engineers that we need. But we don't need only engineers, we need technicians, we need a lot of welders. And I was so glad to meet with Around State Community College, which has a wonderful welding program. And all these jobs that we need for our plant cannot be replaced by AI. We need actual welders, we need actual technicians, and it will require a lot of training and a lot of programs developed with local universities and colleges that we have started to implement thanks to the state of Tennessee. So thank you.
Sure, absolutely. And just so you know, this is we're a Tennessee loving panel, so you're going to hear a lot of rah-rah Tennessee. So if you guys are Vols fans, just let out a cheer and it'll be great. You'll be right along with us. Matt, so Jason mentioned, I guess the elephant in the room around AI, data centers. What is TVA's approach to that? What's the strategy for meeting the significant increase in energy demand from those projects? And then how are you planning to address those?
Well, it's a great question because it is, I think, the greatest challenge of our generation. I mean, we are on the cusp of an industrial revolution, a new industrial revolution. And it is real. And we see it every day. A lot of you see this every day. We have over 6,200 megawatts of current projects in the pipeline for construction. All right. Give you an idea, we have projections of upwards of 2 to 3 times the size of our current grid. How we have to grow that in the next 30 to 40 years. It took 70 years to grow the first part of that. And so really, it's going to take a lot of effort. I jokingly say, if I could strap my mother-in-law to a stationary bike with a generator on the back and hook her up to the grid and thought she'd be cost effective, I'd do it. Right? I mean, we really are. Don't tell her I said that. Hopefully this isn't live. But I'll be honest. We really are taking an all-in approach. We're taking an approach of we have partnerships. If you think about some of the recent Type 1 this morning, right? The governor was in Bull Run this morning with our partnership with the Fusion Group of the Type 1. We've got our Kairos. We've got Oklo. We've got the Intra 1. There is just and we've got our GEH, BWX 300. So we are really laying the foundation for the Tennessee Valley to be the birthplace of a nuclear revolution. And the support we get from the state is absolutely incredible.
Sure.
I mean, the ecosystem that we're establishing in this area is really incredible. So that's one piece of it. The partnerships we're establishing, I jokingly refer to it as the field of dreams approach. We're going to make this area such a fertile ground for new nuclear development that people will want to show up, right? So they're going to want to be here. And so we're supporting that piece. We have a very extensive gas build out ongoing right now. We're bringing thousands of megawatts online every year from our gas build out. A big piece of it is preservation of our current assets. It doesn't matter where you're on your side you're on. At the end of the day, like our coal plants, we're going to continue to operate them right now. We have to. We need them for the basic electric system. We're also going to have some build out of renewables, but it is an all-in approach for us. We recognize the need, we recognize the demand, and this isn't an opportunity for us to make a bunch of money, right? That's not our model. Our model is to deliver you all the most affordable electricity we can possibly provide you, and do it as quickly as we possibly can as well. That's our model, and that's what we want to accomplish. So it's an all-in approach with partnerships, some government, some private, to make it a reality for everybody in the Tennessee Valley.
Very good. Jason, I want to build off that. So it was mentioned kind of speed to market. This is fast-paced. We've got a lot going on in a short amount of time. How are you all working to ramp up capacity and ensure solutions for these fast-paced developments, and maybe what challenges are you facing and seeing in your sector?
Sure. So I think as a manufacturer, we're onshoring as much as we can here in the States and expanding capacity and trying to extend that to our sub-suppliers as well. But we're also trying to innovate, right, and make sure not only expanding our capacity, but coming up with innovative solutions to deliver kind of rapidly deployed solutions to support interconnection of substations or SMRs. So, something as minor as standardizing on specifications for something like a power transformer has major ramifications and benefits for the industry overall. So whether it's regional or by customer or by manufacturer, it allows us to be more efficient as a manufacturer, allows reliability and certainty for our customers as well. And we're trying to innovate around other rapid deployment type strategies, everything from modular substations and almost like building blocks of these substations, and taking our high voltage switchgear, medium voltage switchgear, and basically expediting how we manufacture and install them on site, right? I talked about construction resources being tight, so the more that we can do to minimize maybe some of the on-site construction, it can alleviate some of that stress, but also expedite some of the solutions. So capacity has to be added. So we're doing that. We're adding capacity in Memphis, and we're going to be expanding and onshoring the other solutions we have as well. But we're also trying to be innovative in terms of other things we can do with the existing capacity to get solutions out to partners like TVA quicker.
Sure. Fantastic. Jean-Luc, want to pivot to you, and I'm going to make this joke. Maybe I've overkilled this joke, but so HALEU, fuel, I was in East Tennessee, as I mentioned this morning, and about 2 years ago, my background is I'm a Bachelor of Science in political science, not anything close to nuclear science. Actually, a graduate of Belmont University, so glad to be back on Belmont's campus. But HALEU was first mentioned to me 2 years ago. I thought that was one of those cool, hip tech company names from Silicon Valley that someone made up in a basement somewhere that just sounded cool. But it's an acronym, high assay, low enriched uranium. Can you talk to us about, a reliable fuel supply chain? How is Orano adapting its enrichment and fuel services to support the diverse needs of these advanced reactors? How does HALEU play into that? The different enrichment levels. Just talk to us about all things fuel.
Wow. So I will be brief on HALEU and LU. So LU stands for low enriched uranium. This is enriched uranium. It's a uranium that is enriched up to 5%. And that is currently used by all the light water reactors that we have in the United States. So the 94 reactors in those from PA, they burn low enriched uranium, what we call LU, up to 5%. HALEU, high acid low enriched uranium, is enriched up to 20%, and what will be used by the advanced reactors. So today there's only one facility in the US that can produce HALEU on a very tiny quantity that is located in Ohio. Our priority is really to produce LU so that the existing fleet of light water reactors will have access to a secure, diversified, and competitive source of enriched uranium. But of course, our plan will be to expand our capacity as soon as we are done with phase one to produce more LU for our customers, or potentially HALEU if there's a clear market on this. So today, it's a chicken and egg story because the hyperscalers, they are asking the advanced reactors to have their reactors online, We are talking to them to say, please give us some offtake contract. They are saying, no, build your plant first, and after we'll send you offtake contracts. Fortunately, the Department of Energy, thanks to Congress, got some funding to jumpstart new HALEU enrichment capacity. So there should be some HALEU enrichment plants, but to come back to our investment in the state of Tennessee, our priority is first the HALEU as phase 1, but phase 2, I'm sure that we'll start to produce HALEU for the advanced reactors.
Very good. And John-Luc, as a follow-up, can you talk a little bit about how important it is to have federal investment, additional dollars that are coming in to help make this isn't a cheap operation that you're talking about.
So so I told you that for phase 1, it's a $5 billion investment. So $4 billion will come from my company. In fact, will come from France. That's why it's the largest foreign direct investment ever made in the state of Tennessee. And currently, so Congress in 2023 decided to allocate $2.7 billion to DOE to jumpstart new enrichment capacity so that investment will be made in this country to stop the reliance on the import of Russian enriched uranium. So there's currently an RFP process. I cannot go into the details because we are one of the awardees. But our goal, I would say, is to get about $1 billion from the US government to help us accelerate the deployment of our enrichment capacity in the US. And what is very important, and I'm glad to have my customer here, TVA, all our customers I met with, they all told us, not TVA by the way, but the other ones, they all told us, we want to have enriched uranium produced in the United States for national security, but we don't want to impact the cost of our ratepayers. And therefore, we would never pay a premium for production made in the US. And the only way for us not to charge a premium is to get access to this funding from DOE because it will help us reduce the financing cost of our investment. But in any case, $4 billion will come from France, be invested in the state of Tennessee.
Very good. So Matt, you mentioned the Clinch River, and I'm going to hold you to everything that you're about to say. As the nation's only early site permit for an SMR, what is the timeline, key milestones for the project, and how will its successful deployment serve as a model for other utilities in the U.S.? And be as specific as possible, speak right into the mic.
Yeah, I understand. Yeah. So just talk a little bit about timeline. So as I mentioned earlier, we have submitted a construction permit application. So for those of you who aren't aware, there's multiple ways in which to build a power plant with regards to the regulatory construct of that. You can build it in something called a combined operating and construction license. So you get a license to build it and to operate it all at the same time. There's a lot of risk in that for a first of a kind cost. What that means is if you use that approach when you go out to build the power plant and you have to move a pipe from here to there, it's licensing work to do it, right? Which makes it really, if you've ever built anything, it makes it really hard. The advantages of a construction permit application is if you need to move the pipe from A to B, you do it, right? And so it's just a lot easier for initial construction. Now, once you build 20 of them, you can use the combined approach to do it, and you can build it because you know exactly where the pipe A is always going to be where pipe B is. So we submitted the construction permit application. The NRC is in review of that right now. So we're answering something called RFIs, request for information, and we'll do that really over the next year, a little over a year. We're expecting to get an approved construction permit application from the NRC in early 2027, what that means is you can build the power plant. That doesn't mean that you've got the funding or the partnerships to do it, but it means you can build it. The great thing about that timing is that OPG, who's building the similar design right now, will be pretty far under their construction. We'll have a very good insight at that point around what the cost of that is, what the challenges they've had has been, and we can incorporate that into our estimates. And so we can bring all that information to bear to our board in that time frame through our very regimented process, intentionally so, to make sure that if we move forward, it's the right thing to do. And so I would say that's really the decision time frame, is the partnerships there and the support there, and having board alignment in that 2027 time frame.
Sure.
That's when we would potentially say, let's go build it. Now, I will say, if you go out to Clinch River today, we are moving dirt. We're doing things, right? We're getting transmission assets set up. We're building roads. We're getting water put in. Like, we're getting it ready to build a power plant. It looks like a construction site because we're going to put something in Clinch River. I feel confident that we're going to do that as we progress forward, and I'm excited about that.
Very good. I was going to do a quick follow-up. So you mentioned the timeline of kind of NRC. What have you seen over the past, 6 months with some recent legislation that's passed that's kind of sped some of those things up with the Advance Act and some other actions at the federal level? How much has that sped up that 2027 timeline for maybe what previous timelines were?
Quite a bit. The ADVANCE Act has really done a lot for us, and it's done a lot for us not just in new nuclear construction, but I'll give you one great example of new nuclear construction. The typical timeline for the NRC is 36 months to review a construction permit application. They're going to review it in less than half that. And then we're going to be in a great place where we are extending the life of our current assets. So Browns Ferry Nuclear Plant, if you don't know Browns Ferry is in North Alabama, it's the largest power plant in the country under one roof. 3,900 megawatts under one roof with a 95% capacity factor. That license renewal came in roughly 6 months ahead of time from the NRC, and about $4 million under budget. So we're seeing a lot of the work that our representative leaders have done in DC over the last couple of years really make an impact. It's really, at the end of the day, it's making an impact to the ratepayers, is what it's doing.
Very good. Jason, can we talk a little bit about cybersecurity, physical security of your transformers? How have you guys worked on protecting your assets against potential threats, maybe specific to nuclear facilities and the broader energy infrastructure?
Sure. Yeah, I mean, I think it really is driven by companies like TVA, Matt, and utilities really driving manufacturers to innovate and ensure, we can make things that are physically secure and NERC, SIP, and things and programs that have been developed. This has been worked on for 15 plus years. So, from our aspect as a transformer and a solution supplier, it's, for example, on transformers, it's building some resiliency into the transformer itself. So the type of materials that we utilize, the size of the unit, so you can put protective walls around it, for example. Even how you connect the units to the transmission grid or distribution system, and the materials utilized rather than porcelain using something like a composite. So there's definitely been a lot of work over probably the last 15 years for physical security of transformers. It extends to other equipment as well. So we do a lot of switchgear business, high voltage and medium voltage. So the innovation to shrink the size of these high voltage, medium voltage substations so it's economical for a utility or generator or developer to put those in buildings or even have us ship them in buildings. So these are substations that may not look like a substation, and they're physically secure because the nuts and bolts, the internals are inside of a building. So innovating around dry air insulation and minimizing the size is grown by leaps and bounds, I'd say, over the last 10 years. From a cybersecurity standpoint, data is being used more and more, right? It's exciting here about AI because we're serving the AI industry and data center and Bitcoin industries, and we're utilizing that technology on our manufacturing. So there's more data available, right, for asset health of equipment. It's amazing to see how utilities have protected that. So when we're building nuclear, it's not like this is something new. We've been doing this as an industry for 15 plus years, physical security and cybersecurity. So that should not be a concern as we go. But again, it starts with utilities, the generators, the developers that set the standards. It trickles down to us to take those challenges and then innovate solutions around it.
Very good. John,
I will say I really appreciate this comment about innovation and materials and things like that in the area of resiliency. Because, if you would have told me we would have seen 0 degrees in the Tennessee Valley, I would have told you, no, we're never going to get to 0 degrees in the Tennessee Valley. But we did, just fairly recent, the last couple of years. And if you would have told me that there was a 40-degree change between one day to the next, I would have told you, no, that can't happen, that we're not going to have it happen. So I really think how we design our new facilities, how we design the electric grid of the future, keeping that mindset of resiliency and adaptability as part of that design is just really, really important.
Very good. And John, I want to build on kind of the security aspect, safety. What measures is Orano taking to enhance security and transparency through the nuclear fuel cycle? And how does that lead to public trust and support in building that? We definitely want to make the perception that nuclear is a safe form of energy. And what are you all doing to kind of build that trust?
It's a very good question. So first, safety and compliance are our values, are our priorities. Everything we do is we do it in full compliance with the regulations, and we are also in the direct contact with the public. In France, we have facilities. We have a reprocessing plant in Normandy, and we have, public hearings almost every month to make sure that we address all the concerns from the constituents. Before we will build our enrichment plant in Oak Ridge, Tennessee, we'll make sure that we'll have also public hearings. And I think I've been now in Oak Ridge like 20 times. I had the pleasure to speak with the city, the constituents of the city of Oak Ridge, of Warren County, of Anderson County, and every time there's a concern, we are here to address them. In terms of security, this is an enrichment facility, so it's more a chemical plant than a nuclear plant. However, we have to make sure that no nuclear materials will be taken out on an irregular basis from our plant, so we'll have guards. In fact, the security cost is our largest operating expenses, but this is necessary. We want to make sure that no nuclear material will be stolen from our plant. This is really key. Also, we do a lot of upfront communication. So there's another activity that we do in the United States. We are one of the, I would say, the leading companies in the transportation of nuclear materials. And what we love to brag about is that, like 4 years ago, we transported the most radioactive components from the dismantling of a nuclear power plant from the state of Vermont to the state of Texas for disposal. We work ahead with 10 states, with the city halls, with the firemen, with the tribes, with all the counties that we went through transporting this nuclear waste, and you heard nothing in the press. You see no demonstration, nothing, because we work in advance to ensure that we will address all the concerns from the constituents. So this is really our policy. We want to anticipate, we want to make sure that there is no concerns, and if there's any concerns, we're here to address them. And one of the coolest jobs in my company, I will tell you, because we transport nuclear spent fuels from Japan to France, from Australia to France, and there's a guy in charge of talking to all the small islands in the Pacific Ocean to explain what we are doing. It's one of the coolest jobs, so if you're looking for a job where you will travel from one island to the other island for 6 months in your life, please call me, because we may have an opening in the near future.
There you go. We'll put your number on the screen. You guys can it'd be great. So we've got a few minutes left. I wouldn't be doing my job as a voice of the state of Tennessee than to ask each of you, why Tennessee? Why do you think Tennessee is leading the nation in energy? And as you're thinking about that, I'll give you 15 seconds. So just to give you all a sense of just how big this nuclear opportunity is in the state, over the past 2 years, we've announced projects that have been over $10 billion in new investment just in nuclear, close to 2,000 new jobs. We have more coming. We have great interest from companies in the nuclear sector, in the nuclear supply chain. So we are really building Tennessee as a nuclear hub and the place where you can do this and be welcomed and supported. And so I guess I turn to you all. What do you see, what about Tennessee screams out to the rest of the nation that we're the place to be leading and how we've been leading? So Jason, we'll start with you.
Sure, yeah, I'd be happy to. So I think there's a lot of reasons, right? We were initially going to build a plant here in the U.S., Greenfield. We worked a lot with the state to find potential greenfield sites, and just seeing the support from the state, right, for new manufacturing here. But Memphis was such a good fit for us, and Tennessee's such a good fit. It's the access to the workforce. We've grown to over 450 employees in Memphis. We're going to have 800 by 2028. And the logistics as well, right? Memphis, we know, is a logistics hub, but it's in the vicinity of our customers in the Pacific Northwest, in California, New England, and Florida. So, Tennessee was new for us. I started with the company in 2001. We're headquartered in Pittsburgh. I'm guilty. I'm a Pittsburgh Steelers fan. Sorry if I offend anybody here, but it's a welcoming state to do business. And I think it's the universities, it's access to tremendous workforce that really sealed the deal for us.
John Luke?
So, to come back on Project Ike, our big investment here in the state of Tennessee, initially we wanted to do it in the state of Idaho because we own a site. We're ready to restart our design activities in Idaho. I hope that there's nobody from Idaho in the audience because I don't want to receive potatoes on the stage, okay? So there's nobody good. But then we decided to do a site selection process, and we have been so much impressed by the vision of Governor Lee, the TNECD, what you have done, that with support that we got from Senator Blackburn, Senator Haggerty, and in particular Congressman Flashman, that is so much in favor of nuclear energy, but also the support that we received from the local mayors, so Mayor Gooch, Mayor Cresswell, Mayor Frank. They've been so supportive, and the local community. I had the chance to talk to the public in the city of Oak Ridge. They were so much, as I said, supportive, so much embedded in the nuclear culture that we say this is really the place to go. But as I said earlier, the big difference was really the training program that the state has established with the local universities, colleges. This is really impressive because we can build plants. But if we don't have the right workforce to operate the plant, these plants are useless. So that's why we have been so impressed by the state of Tennessee, and this is a great place to be.
Well, those are all really great things. So I will tell you, in my business, you become a student of history, right? Because you study. You study the past, so you never repeat any of those events if these things occur. But you also study the really good things that happen. And I think about the birthplace of nuclear power. There's three areas that you could say are the birthplace of nuclear power. You could say it's the Chicago Pile, underneath the stadium steps at the University of Chicago with Enrico Fermi. Same time, you could say it's Los Alamos Laboratory. They're developing the Manhattan Project. But I will tell you, it's Oak Ridge, Tennessee. And Tennessee is the birthplace of nuclear power. And shame on us if we're not leading in the area of nuclear power. And our represented leaders, so Governor Lee, Senator Haggerty, Senator Matt Blackburn, Representative Fleischman, and all the other ones, to be honest with you, just about everybody in this state could not be more supportive. And they have created a fertile ground to develop and grow here. The workforce is a big piece of this. I will tell you, if you don't know, the University of Tennessee is the largest graduate nuclear engineering program in the country. As an Auburn graduate, that's hard to hear sometimes. But I will say, like, it is world class, absolutely world class. And then the availability of our trades people here in the Tennessee Valley, the partnerships we've got with the union who want to make all this work, like it is an impressive area to really launch what I believe is the revolution in nuclear power that I'm just couldn't be more excited about.
Very good. Great way to wrap this up. Thank you, panel, for your time. Thank you all for listening, and enjoy the rest of the conference. Really appreciate it.